Hi folks, we're going to take a look at number 7 from page 415. So they give us these 3 points, which are the vertices to a triangle, and they want us to find the area specifically using the angles given. Okay, so if I have, say this is triangle A, B, and C. Okay, so they ask us to use vectors AB and AC. Now, first of all, why can we even do that? Okay, well, what we can do is we can use the fact that the cross product, or the magnitude of the cross product, gives us the area of this parallelogram, and the triangle formed by ABC would just be half the area of that parallelogram. Okay, so let's start with that. Okay, so first let's find AB. So AB would be equal to 1 minus 2, so the 1 minus negative 2, so that's going to be 3, then 0 minus 1, negative 1, and then 1 minus 3, negative 2. Okay, then we've got AC. Okay, so that's going to be 2 minus negative 2 is 4, 3 minus 1 is 2, and 2 minus 3 is negative 1. Okay, and I'll just go from here since they're above each other, so put a 3 and a 4, and I'll find the cross product and take its magnitude. Okay, so I need the magnitude of AB cross AC. Okay, and in fact I'm going to take half of that, okay, since I'm looking not for the parallelogram but for the triangle. So it's half times, okay, and let's find the cross product. So here we have 1 minus negative 4, so that's 5. Here we've got negative 8 minus negative 3, so negative 8 plus 3 is negative 5. And then here we've got 6 minus negative 4, so 6 plus 4 is 10. Okay. And so here we're looking for half of that magnitude, so half of square root 25 plus 25 is 50, plus 10 squared is 100, so 150. Okay. So this is the area of the triangle, and of course you can simplify that, but I'll leave it as is, using these two angles. Okay, so if we go to B, okay, so we still have the same triangle, A, B, and C. This time here, though, they want us to use BC, okay, and CA. Now the first thing I notice is that these two vectors are not placed tail to tail. Okay, but think of it this way. Even if I move this vector here, so this is the triangle I'm trying to find, but even if I move this vector CA up here, I see that I still have the other half of that parallelogram. Okay, so even if I take the cross product of BC and CA, I think of it this way, placed tail to tail, it's still giving me the exact same parallelogram, and so half of that will still be the area of the triangle. Okay, so just needed to justify that, since of course we set these all up to be tail to tail. Okay, so let's go ahead and do that now. So first let's find what is it we're using here, BC. Okay, so BC, it's mean negative 2 minus 1 is negative 3. Okay, and then, oh, sorry, I just realized I did the wrong one. So BC, this is what we're trying to do. So let's try again. 2 minus 1 is 1. Okay, so that's just a funny one. Okay, 3 minus 0 is 3, and then 2 minus 1 is 1. Okay, and we'll put the 1 on the end since I'm going to take the cross product. And the other one we want to use is CA. Okay, so CA. So negative 2 minus 2 is negative 4. That's the correct one. Okay, 1 minus 3 is negative 2. And then here we've got 3 minus 2 is 1. And so a negative 4 there. Okay, so again, I want to calculate half the magnitude of BC cross CA. Okay, so that's 1/2 the magnitude of, so let's find the cross product. Here we got 3 minus negative 2, so 3 plus 2 is 5. Negative 4 minus 1 is negative 5. Well, this is looking pretty promising so far. And then here we've got negative 2 minus negative 12. So negative 2 plus 12 is going to be equal to 10. Okay, and I don't really have to do much work here since I'm going to get the exact same magnitude of 150. Okay, so what we're getting here is that no matter what two vectors we use, we're getting to the same area. But that should not be at all surprising, since, if you think in general, if I take this triangle here, that I use this as my base, or that is my height, or I use this as my base, and this length here is my height. In other words, I've just flipped the triangle around. I should get the exact same area. So it shouldn't matter which sides I'm working with. I should get the same area of the triangle. Okay, so our conclusion, any two sides can be used to find area. Okay, so just to recap here. Okay, we were given the points, and what we need to do is take the cross product of the vectors. So we had to create our two vectors. From there, we had to find the cross product, and then since we were looking for the area of the triangles, we were taking half the magnitude of the cross product. Okay, that's it for this one.